algebra students, and for our final unit or lesson for 8.6, we're going to be reviewing how we can tell if a function is linear, exponential, or quadratic when we're looking at a table of values. So linear and exponential should be review. When we notice our domain is increasing or decreasing by a common value, we look at the changes to our output or our range. Notice when we see the first difference or the common difference is a constant, then this means that we are dealing with a linear function. This means that our slope between any 2 points will be the same or constant, and therefore we would have a straight line. So again, when you have a common difference that is constant with your output values, then you have a linear function. If you look at your outputs and you notice that there is no constant difference, then what you can do is you can check the second difference. So here we notice that we're adding 6, then we're adding 10, we're adding 14, and we're adding 18. This is what we call our first difference. If we now look at the second difference, we look at the change between these two numbers and we get 4. The change between these two numbers is 4, and the change between these two numbers is 4. If you have a constant second difference, this means that we have a quadratic function. If you do not notice a constant first or second difference, look to see if there is a constant ratio. Notice from here to here we are multiplying by 2, times 2, times 2, and times 2. As you recall from an earlier unit, when we have a constant ratio, we have an exponential function. So here we have a table of values, and we are trying to decide whether or not this models a linear, exponential, or quadratic function. Starting by looking at our input data, we notice that this is increasing at a constant rate of +1. So now we're going to look at our output data. Starting by looking at the constant difference, we notice here that we are adding 2, but here we are adding 6, here we are adding 10, and here we are adding 14. So we know that there is not a constant first difference, therefore it cannot be linear. So now we're down to either exponential or quadratic. You should check for a constant second difference. So now we see that between these two we add 4, between these two we add 4, and between these two we add 4. Therefore there is a constant second difference, which means that this models a quadratic function. Pause the video and look at the following two tables. Determine whether or not each of the tables represents a linear, quadratic, or exponential model. When you're ready to check your answer, resume the video. So again, we want to start by making sure our input data is increasing by a constant value, which it is. We're going to start by looking at our first difference. Here I am adding 3. This is adding 9. This is adding 15. And this is adding 21. Therefore, it is not linear. So now we are going to look at a constant second difference. This is adding 6, this is also adding 6, and this is adding 6. Therefore, this is modeling a quadratic function. Moving on to our next table, again we are adding 1 each time. When we look at our constant difference, this is adding 8, this is adding 24, and I'm seeing that these are increasing quite quickly. So this could be a hint that this would be exponential. So I may take a pause here And instead of going on with my constant differences, I may decide to go ahead and check to see if there's a constant ratio. I notice that this is times 3, this is times 3, this is times 3, and just to double check, I could take 324 and divide it by 108, and I see that that is also times 3. Therefore, this is exponential.